In this video, we'll be solving another boat in the river problem. A boat travels for 3 hours with a current of 3 miles per hour and then returns the same distance against the current in 4 hours. What is the boat's speed in still water? And then how far did the boat travel one way? Now this is called a boat in the river problem. This one actually is, but the thing that we need to be aware of is when we're traveling with the current, the speed of the boat is increased, and then when we're traveling against the current, the speed of the boat is decreased. Now when I work this problem, I usually organize my information that I'm given into a graphic organizer. I call it my dirt box because I use the formula distance equals rate times time. So my distances will be in this column, my rates will be in this column, and my times will be in this column. And when you have a boat in the river problem, you have with the current and against the current. Now let's read our problem again and fill in our information. A boat travels for 3 hours with the current. So our time with the current is 3 hours. And I'm going to save this fact that the current is 3 miles per hour. I'm going to save that for a little bit and continue reading. Returns the same distance. So the fact that we have the same distance means that we're going to use a variable here for our distance, and we'll just use d to stand for distance. Returns the same distance against the current in 4 hours. So the time against the current is 4 hours. Now the thing about boat in the river problems is that when you're traveling with the current speeds up your boat. So I'm going to use B for boat, and I'm going to use C for current. And to speed up the boat, I add the current. Then when you're traveling against the current, the boat is slowed down by the current. So your speed of your boat minus your current is what goes in this cell. Now let's come back to the fact that the current is 3 miles per hour. So I can use this information right here, in place of C in this rate. So I'll actually write B plus 3 here. And then this one will be B minus 3. All right, once I have all of the cells in my dirt box filled in, I can get my equations. I have D, and then I use equals, and then my rate is B plus 3. Now that's a binomial, so I'll put it in parentheses, times my time, which is 3. My other equation, D, is equal to my rate is B minus 3, again put it in parentheses, times the time, which is 4. So let's go ahead and distribute these. This 3 goes through this binomial. So I have distance is equal to 3b plus, and then 3 times 3 is 9. And we'll distribute this one also. So my second equation, D is equal to 4B minus 12. So this is a system of equations in two variables, B and D. Since they're both equal to D, I can set them equal to each other. So 3B plus 9 is equal to 4B minus 12. Let's subtract 3B from both sides. These will cancel. I have 9 is equal to 4B minus 3B is 1B. And then I still have minus 12. Let's go ahead and add 12 to both sides. These will cancel. And I have B is equal to 21. Now B stands for the rate of the boat in still water. And so I'm dealing with miles per hour. So this is the label on this answer. My boat can travel 21 miles per hour in still water. Now I'm also asked, how far did the boat travel one way? So I need to find the distance. So let's use this equation. Distance is equal to 3B plus 9. And we'll put 21 in as the value for B right here. So distance is equal to 3 times 21 plus 9. Do the math. Distance is equal to 63 plus 9. So my distance is 72, and that would be miles.